Hi, and welcome to this next tutorial in FME, where we will solve some practical problems that I have encountered in my work, and at the same time, see how different transformers can be used in FME. And the cool thing with this process or this series is that I bet there exists a lot of different solutions. So if you find a solution that is better or different, it would be really nice if you commented below and share it with us so we can learn from each other. So I'm going to start off by explaining the problem for this tutorial. So it's about, in my work as a water and environmental engineer, we use modeling softwares to simulate the behaviors of water distribution systems and wastewater transport systems. So the task here is to distribute the population increase towards the year 2100. And the goal is that we want to capture the distribution as best as we can. So, and with data we have. And the data we have a point shapefile with the number of people that lives at a specific point in an area. We have a polygon shapefile of sub-districts, and these sub-districts polygons contain information about the population growth in percentage from today's population. So if it's 25%, it means that there will be 25% based on the today's population, which will come in addition in the year 2100 has hit. And the next data we have is another polygon shapefile, but this is a shapefile of development areas where we know there will be intense building. So it's like a hotspot for where the population increase will be most significant or the biggest. And that shapefile contains the number of houses that will be built within these areas. So we have to assume how many people will be living in these houses, but that's just an assumption. The process will be the same nevertheless. And so just to show it visually, we have the point shapefile. Each point contains a number of people living at a specific point. And just to make this clear, this is just made up data. This is just mock data I made in 5 minutes. So it's just fictional data. And the sub-districts, the polygon data, we have for this fictional example, we have three features. So each feature represents a sub-district with the growth percentage. And we have the development areas or the hotspots for the population increase towards the year 2100. As we see, there are some overlaps. So the goal is that we want to use the population increase in our modeling job. So we want to have a model where the hotspot effect is considered. We don't just want to evenly distribute the population increase in the whole area. We want to consider the hotspot effect where we have intense building and where there will be more people living than elsewhere for the population increase. And then when we have considered these spots, then we will subtract these from the sub-districts, and the remainder of the population increase in the sub-district, when we have subtracted these, they will be evenly distributed across the remainder of the sub-district. So I hope that makes sense. If not, I think you will see it clearly when we go to the solution, or my approach to the solution. I hope other people will try to solve this as well. So my approach to solving this is to find today's population in each sub-district And then we find the number of people that can be housed in the development areas. And then we need to do the spatial manipulation where we have to subtract the population increase in the sub-districts based on the information we have from the development areas. So we just keep the polygons from the development areas, but we want to subtract these hotspots both numerically when we talk about the number of for the population increase, but also spatially, that we want to clip the part of the polygon which is overlapping the sub-district. This is because we're going to use the areas to distribute the population increase. Because you see, for this project area, which is called project area 2 here, you see that this portion, this sub-district, has more of this hotspot than, for example, this sub-district. It's just a little portion here. So we are going to use the area of the polygons to distribute these the population increase from the development areas. So that's basically it. We keep the development areas, and then we just subtract that information from the sub-district. So just to give you a visual representation, our starting point is our data, and we want to go toward our goal, which is the population increase due to development areas, which is pretty simple to accomplish. And then we have the population increase in the sub-districts when we account for the development areas. We don't want to include them twice, so we have to subtract it. So that is it for the explanation. And again, I hope you will try to solve it yourself, so we can get some different perspectives and learn from each other. But now I'm gonna head over to FME Workbench, and I will go through how I solve this problem. So here we are back in FME, and I have just imported the data. If you're not sure how we do that, I suggest you watch the previous videos in my FME series. But I have made some bookmarks to keep track of things, but for the transformers I will just use the annotation to list everything we do. But if we inspect the data, it's like I showed in the PowerPoint presentation. We have the different features representing the sub-districts and a growth attribute column which says something about the population increase towards the year 2100. So if I click on this one, we can see that this sub-district will have a growth of 75%. So pretty big increase in this area. And we look at the population data. It's just points with the population. And we have these project areas where we know the number of apartments that will be built within the area. So to start off, we need to find for each sub-district how many people lives within each sub-district, and we will use the point shapefile to do that. And the first transformer we're going to use is the point on area overlayer. So it performs a point in polygon overlay, so we can combine the information from the point shapefile and make it go to the feature that the point is overlaying. So if the point is overlaying this feature, it will go into that feature. So we just connect to our transformer, and then I can try to give the annotations for each step. So here we like this, and we press the cogwheel. So we want to merge attributes here. So we will choose the merge attributes and keep the default as it is. and we want to generate list on output point, because we want to give each point an attribute that says this point is within this subdistrict feature. And the attribute we want to give is the name attribute. And for the point list name, I will just call it subdistrict, like this, so we can see when we run this transformer. Just one thing that I think we should just change right away. My bad for making the data, but now we can use another transformer, the attribute manager, because I think it's just to just call it the subdistrict name. I think we should just call it what I just said, subdistrict name. So we will take rename, and instead of calling it name, we will call it subdistrict name. Just so it will be easier to follow along later. And we'll connect this. We will click the cogwheel. Now there's no attribute column called name, so we have to choose the subdistrict name. And everything the same. We'll press OK. We run this transformer, and we view the point data, where we see that the point data now has a new attribute column, which is called subdistrict name. And it also received the other attribute column, but we have grouped them according to where the point is, which feature of the subdistrict the point is laying over. So while we have this, we want to aggregate, or that's how I solve this problem. There's probably different solutions here, but now I want to aggregate everything based on the subdistrict name, so that we will only have one subdistrict feature. So the population will be summed. So for that purpose, I chose to use the aggregator transformer, where we'll take our point data, and I will just quickly write the annotation like this. We press the cogwheel. So we want to use the group processing, because we want to group by the subdistrict name. This is what we want, and we would like to sum the population when we group by the district name. So for that, we use the attributes to sum here. And we know the population is what we want to sum. So that's basically it. You choose which you want to group your features by, and then what attributes you want to sum. We press OK, and we run the transformer, and now we see we have grouped them, the points, like this. And we have only one subdistrict name again, with the population summed. So now we want to combine the information from the point data, which we have here, which is grouped, with our subdistrict, so we can get our polygons back, because we will need the polygon later. So I choose the feature merger. We have used this one previously in the other videos, so I'm not gonna go into depth of how we use that one, but we will use the point as the supplier, because we want to supply the polygon shapefile with the information from the grouped point shapefile here. And in the cogwheel, we will merge them by, let me see. Oh yeah, of course. I should use, after I've changed the the name. So I will take it from the attribute manager here. It would probably be easier to see if I have annotated this one. So change the name of, and for this one as well, we will like this. And now we can press the cogwheel, and we want to merge by subdistrict name for both of these inputs. And that's basically it. So I'll press OK. I will run this transformer. And now we can see we have the polygons along with us. So further on, I will use the expression evaluator like this, and I want to do an expression evaluation on the merged dataset, because the merged one only contains our polygons with the information we got from the grouped points that we aggregated here. But in the expression evaluator here, I will do this like that. And to calculate this, we only need the population for today. So I will take the population that we have just calculated, and I will multiply it with the growth value, because that's what the population growth will be towards the year 2100. So, but we need to make it into percent. So I will divide by 100 so we can do this correctly. And for this expression will become an attribute column where the features will get this number. So I will just call this number of so it will be easier to reuse the attributes later on. So I'll press OK. This is the way to go. And then we run it. And now we can see that we have in our data, we have received a new attribute column with the numbers. So for this subdistrict here, there will be an addition of almost 2,600 people towards the year 2100. So this is how we interpret these numbers. Moving on, as I mentioned in the explanation of the problem, we want to use the areas in order to account for how we will distribute the population increase. So I will use the area calculator. I can probably zoom a little bit out, but not too much, so it won't be too difficult to read the text. But the area calculator calculates the area for your features, and when the multiplier is 1, it will use the units of the coordinate system that you are in. So for me that is meters, so if I just keep the multiplier to 1, it will just be in meters squared. And for this one, I will call it the area of the subdistrict like this. And I will press OK. We run it, and we see that we get a new column with the area of each of these polygon subdistrict features. So the next we want to do is to take use of another import I have prepared here, and that is the import of, I will zoom in. So we will take use of another import I have prepared, and that is the import of the development areas. If we look at the data, we have the number of apartments in each project area. And before we can use this together with the data we left off here with the area calculator, we want to do the calculation of how many people can be housed here based on the number of apartments. And for this, we will use the expression evaluator. So I will just write the annotation here. And we just have to assume a number here. So I will create a new attribute, and I will call it like this. So in order to do this, we need to access the attributes of our data, and we do this through the FME feature attributes. Double click on apartments, and I will multiply this with 2.5. I assume that there will be 2.5 people living in each apartment. And then we run this. And we can see that it will be 875 for this project area, and for project area 2, it will be 1500. So, because we're going to use the areas later on, we will do an area calculator of the project areas. So, like this. Yeah, we'll just keep it at the multiplier at 1, and we can call the area area development projects. Yeah. So if we run this one, we will see that we get the area of each of these project areas. So now we want to combine the information from the project areas with the information of the subdistrict, which we left off at the area calculator here. And how I moved on from this point is that I used the Clipper transformer, which divides candidate feature using Clipper features, so that candidates and parts of candidates that are inside or outside of the Clipper features are output separately, and that you may share attributes between the objects. So I used that one, and I wanted to use the project areas as the clipper and the subdistrict data as the candidate. So here is the annotation for the clipper. This is what we will be doing. So we can just keep everything as it is, but we want to merge the attributes because we want to get access of each of the data sources into this transformer with their attributes, so we can take it further. So I'll press OK, and when I run this, some will be inside and some will be outside, and it becomes evident that when we look at the outside, we see that we have subtracted the project areas from the subdistrict polygons, as you can see. And the ones that are inside, these are the project areas divided by the subdistricts. So you can see that the one I have highlighted here is in this subdistrict, this one is in that one, and as you can see, and we have, because of the division, you will get 2 that are in the same district for this data set, and we will get these 2 are in the same district, and there will be only 1 in this subdistrict based on the different project areas that divided our subdistricts. So I hope that makes sense. This is how I moved on to solving this task. So what we will do now is that we will use the inside information and calculate the areas, because we will use this later to distribute our population increase. So as we see, we calculate the area of the sub-district that have been divided by the development areas. We know the total area of the development areas, so we can use the value calculated here to find the relative distribution of the development areas to the sub-districts. So we will press the cogwheel and we will name this something more so that we can figure it out later. It's the area distributed by development areas according to each sub-district. So if we run this one, we can see that the divided project areas, they have now its own area calculated. But we will use the divided and the total area of the development projects in order to find the relative distribution to subtract from our sub-districts. So now I want to do an expression evaluator. I want to connect the data from my preparation here. I'm just gonna copy and paste the annotation. So here we calculate percentage of the area of the divided development area based on the sub-districts to the total development areas. So I will call the attribute column exactly this. It's the percentage of the divided development areas to the total area of the development project area. So then we just need to do a division, and to see our attributes easier, I will extend this one. So we have the area distributed by development area. Yeah, so this one is the one that we cut based on the borders of the sub-district. So, and I will divide that one by the total area of the development project. And that's it. I will press OK. And just so you understand, when we look at these are the ones that are divided. So we are taking the area of the divided project areas and dividing that value on the whole project area. So we can use this this division, or this percentage that we will get from this division, to adjust the population. We will use that to subtract from the population increase in the sub-districts. So I will just calculate this one. The result will become, like for this one, it's 49.9%. So we can use this to subtract the various. What this means is that I think this project area had 1,500 people. So it means that we will take 1,500 people times 0.52, this whole number, and this population number will be subtracted from the one that we took the subtraction from. So let's say this, it says here, number of new people. So the number of new people is about 3,000. And if this part that we have subtracted based on the project area, Let's say that is 1,000, just for example purposes. Then we have already subtracted it spatially, but we need to do it numerically with the numbers. So it will be 3,000 minus 1,000, and it will then be 2,000 left, and those populations, or that population number, will be evenly distributed across this polygon, so we can keep the population number for the hotspots. So I hope that makes sense. It's a little bit difficult to explain, but when we look at the numbers and when we look at it visually here in the map, I hope it makes sense for you. If not, give me a comment and I will try to explain it on the comments below. So moving on from the expression evaluator, we will do another expression evaluator. We connect the data, give it an annotation. I will just paste it in so the video doesn't become too long. So here we will calculate the number of people in each divided development area according to the subdistrict it belongs to. So what we will do, the percentage I will call this people in each divided development area based on subdistrict. So the percentage we just calculated, we will get that one, which is this one, and we will multiply that one with the number of people that can be housed in the project area. Okay, we run it, and now we can see in our data that for this feature, when we have used the areas to distribute the population increase, for the project area, there will be 748 people here in this part, and it belongs to this subdistrict. So this number will be subtracted by the number that exists for this feature. Just to give you an explanation again of what we're doing here. So now we have come here, and now we want to do some statistics. And for that purpose, we will use the statistics calculator here. Give it an annotation. So sum the number of people that can be housed from development area based on subdistricts and group them so that we only have one feature for each subdistrict here. So that is the goal with this transformer. And in order to do this, we will just again use the group processing because we want to group by features attribute, and I want to do it by the subdistrict name. So I press OK and choose that one, and we want to sum. I have to choose the attribute first, but we want to sum people in each divided development area based on subdistrict. That's what we want to sum. So I click the attribute here, and then I can press the sum. Press OK and run this transformer. And just so you know what we're doing, we calculated this in the previous step. So we have these numbers for the divided polygons. We just want to sum based on the subdistrict name here. So we don't have two of the same subdistrict. We only want one. So we group them together. And now we want to join the original subdistrict dataset with the data regarding the development area portion that falls into the given subdistrict. So for this, we will use the feature joiner transformer. And for completion, I will just paste in the annotation. We have our summary here. You can see on the data summary of the statistics calculator, only one unique value for the subdistrict name, and we have summed the values. So you can see for this one, we know that it was only one here, we can see. And if we look at the value, it's 748. And if we look here, it's 748. And since the other two had two, they were divided and there were two entities of them. You see here, this one and this one, and this one and this one. So it only means that we have summed their values and grouped them by the subdistrict name. And when we use the statistics calculator, we only get the table data. We lose the spatial aspect, and this is why we use the feature joiner to get the spatial information back. So I will zoom out a bit, and I will put this as my left, and I'm just going to take it from here when we calculated the area of the subdistrict. I can do it like this maybe. So you see it comes from the area calculator, and we just put it left and right because we just want to join the two data sets. And I'm just going to do it by subdistrict name. Subdistrict name. Because when I run this now, I'm going to zoom in again. Let me see. For some reason, I needed to put with the spatial information on the left. That is probably because I used the prefer left for geometry handling. So when you want to include the geometry of your data, be aware of what you prefer left or right, and which you put into left and right here when you want to get the geometry data back. And just I did a little bit mistake here. We don't want to use this one. We want to use the areas that has been divided or subtracted. So we want to use the subdistricts where we have subtracted the part of the development area. You see? So we use the outside from our clipper to the left here. Because that's the whole point of this operation. We want to subtract the part of the development area. So now I can run it again, and now you see that we have excluded the development area portion, and we also have the people in each divided development area based on the subdistrict sum. So now that we have this value and we have the total number of people based on the whole area, we have to the whole subdistrict area. We have to take this value and subtract it with this value, and then you get the population increase number for the subdistrict that has been subtracted from the hotspot, which is the whole goal of this project basically. So there were a lot of steps in order to come here. But the beauty of this software and this way of working is that once you have made this workflow and you have made it work, then you can reuse it for other parts. You just need to change your imports. Maybe you need to tweak a little bit here and there on the transformers, but it's built, so you can just reuse it again and again. So that's a huge advantage. So for completion of the annotation here, I will write this here, and I will press the cogwheel. I will call this attribute increase in population in subdistrict when hotspot development are subtracted, which is basically the big goal of this. So in order to do this, we will take the attribute number of new people towards the year 2100, and we will press the minus key or minus sign, subtract it with this one. People in each divided development area based on sub-district summed. And that's it. We press OK. We run it. And just to make our lives a little bit easier, when we're going to use this data in our modeling endeavors later, we can use the attribute manager and just clean it up a bit. So we just include that we just include the things that we want or what we want to use further. So all the calculation steps in between all those attribute columns, we can just erase them. So what I want, I only want to keep the subdistrict name, and people. I need to expand this. So long names for the attribute columns. People in each divided development area, increase in populations. This is the one we want to include. So everything else I will remove except for the name. So like this, and this ID is useless, so I'll just remove it as well. So we will keep the subdistrict name, and we will keep the thing that we eventually was able to calculate, the population increase, when we subtract the hotspot areas. So I will run this one. Now you can see it's much cleaner, and we only have the data that we need for further processing in our modeling work. And when we have this, we can just write it to an Esri shapefile. I will set it to automatic. I will specify a folder here, my results folder. I will give the shapefile a name. So this video is already too long, so I won't use much more time. But now we have this part, and the other part is just to take the, now we have done this long operation to come to this goal with this data, where we subtracted the hotspots from the sub-districts. But we are going to use the development areas as a whole. So for this purpose, we can just take we can clean up our attributes, and I will just take, because we're not going to do any spatial manipulation of these data, the development areas. So I'll just use the attribute manager, And I just want to include what I need, and I just need the number of people that can be housed there to work on further in my modeling work, because I need to know where the population increase is going to happen. So I will just I will keep the name, of course. Stupid. Do nothing. I will keep these two. So I will keep these two. And the same, I can put a bookmark. I will write export. And the same here. This is my export for the population increase due to the development areas. So I can just run this and everything is good. Now we have made our shapefiles that we can use further on in our modeling processes for water distribution modeling, for example, or for other disciplines that I'm not familiar with. I guess you need to use population forecasting and distributed spatially for other modeling and other forecasting analysis. So I hope you found this tutorial useful. It became a little lengthy, but we were able to look at a lot of different transformers in order to accomplish this task. And I hope somebody tries it with a different angle. And something that I hope will come from this tutorial is that maybe you have a different problem and you might need one part of the solution I have for my problem for your different problem, if that makes sense. So I think seeing how practical problems can be solved in FME and in real life, this is how I solved this problem. I think there's a lot to gain from seeing how such a problem can be solved. So again, thank you for watching. If you like this video, it will really help me out if you gave it a subscribe to the channel and like the video. Take care, and I'll see you in the next video.